So let's just do this. Number two, and I'm not going to do all four examples. I was thinking about it on my drive, and I decided that we would be better served if we just do one more example together. And then to make progress on a very lengthy assignment, I'll hand out assignment number, whatever it is, and we can do problems together off of that. And that can kind of serve as practicey notes, but also serve as getting our homework closer to done. Kind of two birds there. So, but let's do one more just for our notebooks. So we had the original problem was -3 minus the root of 9 minus x. And then that was equal to the root of 4x plus 5, right? And had we done anything other than just write the problem down? Had we done the left side yet? Yeah. Yeah. So this is really where the stress will come from is the right side here. I'll tackle the not so heavy lifting. The right side is of course just equal to 4x plus 5. Because when you square something with a radical, you don't have to really do anything. But the left side is the heavy lifting. So anyone want to boldly attempt to square, multiply, double that mentally without showing all of our work? Anyone up for the challenge?
6x root of 9 minus x plus 9 minus x.
It was something like that. You said something in there that I didn't like. Would you like to read it maybe again? And I think you had it, man. Something you said just kind of made me, I liked it, Nick.
No.
Oh, rats. I mean, it's probably recorded, but I don't know if it picks up your voice. So, anyone else want to give it a shot? Okay. So let's do this one a couple ways. Let's first do it the safe way, and that means let's just do what we do if we want to make sure we, in theory, get it right every single time. And that is, we go find some extra space somewhere off to the side, and we actually just write it down old school. So to do -3 minus the root thing squared means to do -3 minus the root thing times another exact copy of -3 minus the root thing, right? So you want to be patient with this process. And again, if you can get to where you can square, multiply, double it, you're going to save a lot of time over the course of the next few days. But if you can't, it's really not a crime. So remember, it takes 4 steps to get through this process. The first one is this red math problem. If you just do it this way every time, it'll work. It always works. So we take the first times the first, -3 times -3 is 9. You've been doing this since algebra 1, right? Just multiplying binomials together. And then we're going to go to the far outside of the problem now. So we're going to take -3 on the outside times the negative root on the far outside. And what does that make? It makes plus, so positive, right? Because it's a negative being multiplied by another negative, and then we get 3 of the roots of 9 minus x. And then we're going to move to the inside. So we now take the two terms that are, of course, closest together, and that's these two connected with green. And what's that going to make? Isn't that the same as the one we just did? Yes, it is. And hopefully we'll all make that connection if we haven't already, is that that's where the multiply double comes from, is that these will always be the same. The purple and the green will always be the same in this case. So it's just another copy of +3 more roots of 9 minus x. If those aren't the same, you're doing something wrong because it's the same terms but just in different locations. And then the last thing is to do this yellow, and that's to multiply the last by the last. And again, a lot of it is pretty basic math. Like it's a negative times another negative, so it does become plus. And then since it's a root times a carbon copy of that same root, then you just lift the root off and copy down what was inside the 9 minus x. Like I'm not holding out. There's not like a backup method for this. I mean, that is how you multiply two binomials together. Okay. And then you would, of course, combine the like terms in the center because they are like terms. It's three somethings plus three more of the same somethings, which will always make six somethings. So we can put those together and call it six of the roots. And you tote around three things and add three more things, you got six things, right? And then we're going to search around for some more terms that we can put together. What do you see? This 9 and this plus 9 are going to go together to make a plus 18. And the order that you put these in at this stage of the game, it's completely irrelevant because we're about to be shuffling some stuff around anyways. And then you have that lonely term at the back. So we've accounted for the 9, the purple, um, the green, and part of the yellow, leaving us with just this straggler minus X that has nobody else to go with. Okay. So, I mean, that's the cleaned up version of what we're going for there, just for the record. Okay. Are you interested in seeing how to do it faster? Would you like me to walk through that with you? Maybe it'll stick for some of you and some of you it won't, and that's okay. But let's go through the quicker way to do it. So I'll show you how to do the square, square, multiply, double. And like you know how to do it. You just think that this is a lot, like it looks a lot harder to do, but really fundamentally it's identical. So the way I attack these is so if I'm a student, I might pick two colors to use, or I might just use my pencil. I don't know. But it's important that you first identify that you have a term, Mr. Red, and you have another term, Mr. Purple. And you really need to embrace those four words: square, square, multiply, double. And so the square, square means that we're going to take the red and we're going to square it. And when you square the red thing, what do you get? You get 9. And then you square the purple thing. And what do you get? Mm-hmm. So if you square red, you get 9. If you square purple, you get plus 9 minus X. So that's the square square. It's where that word, the verbiage comes from. And now the last part is multiply double. And believe me, this is a lot faster when your teacher isn't going through it slowly like this. It really is fast if you let it click. So take the red thing and the purple thing, multiply them together by each other. What do you get? If that's stumping you, I am very sorry. Some anxiety has gotten the best of you. If you're multiplying the red and the purple, you just go back to what you know. It's a negative times another negative, so it's definitely a positive, and then you just attach them. In algebra, when you try to multiply things that aren't the same flavor, you just stick them together. You just boop, touch them, boop, put them right on each other. So we get plus 3 of the roots of 9 minus X. And then the last word is double. So we've done square, square, multiply, double. And if you double what I have written in yellow, what do you get? You get 6. So the center term is going to be plus 6 of those roots. Okay. And it is quicker, trust me, but that's what it would look like. And you, of course, would notice that that's the same thing as we got over here. It doesn't look the same yet because we haven't combined any like terms, any stragglers, but that's the quickest way to do it. You're going to spend a lot of time on just that step, unfortunately. But anyhow, I'm going to take this now and say that you can replace the left side. So I'm going to get rid of some of my scratch work here, and we're going to take this and we're going to pop it up here. And now we have an equation. And I know that's hard. Well, there's no way to just like sugarcoat it or walk around it. That's not an easy process. What's the next thing that we learned yesterday? What do we have to do? Not yet. If you try to square it right now, I honestly can't even tell you what a nightmare. I have no words to describe how difficult this would be. move everything off away. So basically what you want to do is ideally look at the yellow jelly bean here. If you could get the yellow jelly bean by itself, that would be exquisitely perfect. But we might not be able to because of the six. So we might have to settle for getting this larger yellow jelly bean by itself. That'll work. That'll be fine. So we'll see. We'll kind of make our decision at the end as to whether or not it's sensible to divide off that six. But right now, yellow thingy, whatever, that's priority number one. So like Parker whispered at me, we have to take the 18, move it to the other side, take the X, move it to the other side, and let's get some things like put together. So on this right side, we're going to have 5X because we added the X across. And then on the right side, we're also going to have minus 13 because we have to subtract the 18 to get it across. And we're left with 6 times the root. And at this point, what I was talking about earlier was if these two numbers that I'm pointing at with arrows were like an 8 and a 12, then I would divide everything by 2. If I got really lucky and they were like a 6 and a 24, then I would divide everything by 6, right? But if those numbers don't agree to these terms, then you pretty much want to stay away from that. You don't want to create fractions in a case like this. So we just kind of have to suck it up and say, this is the best we're going to do. This is what she looks like ready to go into step 2. And step 2, remember, is where we have to hit it with another coat of like spray. So in application number 1, we were able to kill the root of 4x plus 5. He's gone, dead, thing of the past. But now with application number 2, we have to kill the other root. And how do we do that? Now we square both sides. Okay, you don't want to mess around with squaring both sides when you've got all those terms all over the place. It's crazy. So we're going to square this, and we're going to square this. One of them is pretty easy. One of them is a little less easy, maybe. I don't know. What will the left side, the red side, become if I square it? We did this yesterday. Say again. 36. Nice job, Walter. That's how you do it. You square both parts. Okay. And you do need those parentheses because 9 minus x has to stay as a quantity. So that's what the parentheses are for. And then the right side is a square square multiply double problem, right? So again, if you want to go old school and go off to the side and write 5x minus 13 twice and then do your 4-step process, go ahead. Not me. I'm going to square the first thing and get 25x squared. And then I'm going to square the second thing and get plus 169. Notice I left a space. And then how am I going to calculate the center turn? Multiply double. I'm just going to take the thing since I follow my teacher's instructions and guidance. I've already circled both of those, just like my teacher said to do. And then I just simply eyeball them, multiply them, and whatever I get, I times 2. So what is 5x times negative 13? Negative 65x. And then I double that to get negative 130x. So we have 3 mountains essentially to climb with every one of these problems. 2 of them have been climbed. We killed one radical. Check. We killed another radical. Check. Mountain number 3 is to now deal with whatever quadratic equation comes our way. And they're often going to be a little bit intimidating like this. Okay. So in this case, we have enough training with this to just kind of know what to do. We're going to distribute on the left, which is going to give us 324 minus 36x equals 25x squared minus 130x plus 169. It's just algebra 101. You don't want to be traipsing around in here with a bunch of parentheses, right? You got to have everyone out free to move about the cabin. And which side are we going to move all of our stuff to, the right or the left? Definitely the right, because 25x squared is like, I'm good right here. All you fools come to me. So 25x squared will sit. How many x's will we have?
Negative.
Solid. Negative or minus whatever, 94x, because we added 36x to both sides. And then what will our constant term be? Minus 155. And this, as was the case yesterday, and it won't always be the case, but these quadratic equations can be a little beastly looking. But we're not going to be scared because, like I kind of tried to drop this on you yesterday, that the problems, they can kind of guide you, and they're not as hard as you think they are. So, one tip I can give you is that with these particular problems and the way they're built, is you're pretty well off to assume that your factors are going to look like this, so that one of them is going to have a 1x. It's like if you wind up with 8x squared, you shouldn't do 4x and 2x. I mean, it might work, but it's not where you should start. You should start with the 8-1 combo. Pro tip. Okay. Basic math, what are my signs going to be? One of each. Knowing full well that we might have to change those later, we're just going to put them in. That's what I'm trying to get across to Algebra 1 right now. It's all about the signs, right? And can you think of two numbers that multiply to make 155? I can think of a few pairs. The first one that comes to mind for me is I know that this number, if the purple number, can be divided by 5, right? And we know that 5 times 30 is 150, but I'm short one pack of 5, so 5 times 31 must make 155, right? So I mean that's the one that's got my attention first is 5 times 31. Can you think of any others? Let's see if we can make it work. 9 won't work because if you add 1 plus 5 plus 5, you get 11, and 11 can't divide by 9. It's good thinking, but it won't work. Let's dig in and try what we have. Let's see if this takes us any place. So let's try. I obviously, listen, I know you're a little intimidated by all this right now, but think clearly and understand how dumb it would be to put the 31 there, right? It's like this ain't your first rodeo. You know that you got to multiply that by 25 and you've way overshot your 94. So if we're going to use these numbers, then let's be smart about it and let's weaken the 31 by putting it here and let's strengthen the 5 by putting it here. And let's just see if the chemistry of all of this, like if it checks out. Okay. And so the idea, remember, with factoring is we don't check all the things that we put in and controlled because we're not idiots. Like we know we made 25 and 155. We're not interested in that. We're interested in these. And I've drawn so many of these in Algebra 1 the last couple of weeks. These guys. What do the outside purple ones make? Negative 125x. What do the green ones on the inside make? Plus 31x. And add those together, what do you get? You get negative 94x. I say these look intimidating, but they're not as hard as you really think they are. There's going to be some kind of ways you can think that are going to get you through there quicker than you probably think you can. Okay, big numbers don't necessarily mean like, oh, the end of the world. It just means relax, find what you can, work with it. And look, we got it. Wow. So mountain number 3 has been climbed. And then the end of this now is to say, okay, so what are my potential answers to this problem? So from the one I'm underlining in red, we have an answer of x equals negative 31/25. And then from the one that I'm underlining in green, we have a potential answer of x equals positive 5. So because we're all, myself included, going to use calculators for what we're about to do, we should use negative 31/25 as a decimal. And if you type that into your calculator, this isn't the kind of decimal that's going to bother a guy like me. It's going to come out to negative 1.24. It's nice. So let's think of this for the next few minutes as around, not around, I don't know why I said that. Let's think of it as negative 1.24. It's a lot easier, I think, to type this into our calculator than it is to be toting around a fraction when we don't need to be. So let's get the pain in the butt one out of the way first. Save that nice, delicious slice of chocolate cake until after you eat all the vegetables, right? So the red one is the ugly vegetables. I should have used green since they're vegetables. Um, so we're going to take negative 1.24 and we're going to go back to the very beginning of the problem and we're going to put in negative 1.24. And you don't have to do the very beginning, right? Do you remember kind of what I said about this? What's the rule? Where could we put our candidates to check them? Sort of a general way to say this. Where could we put them? Where's the line at which we are not allowed to put them in anymore? And actually, I think I'm lying to you right now. I don't think we can put them anywhere but the very original equation. What did we do to go follow the big purple arrow? To go from here to here, what did we do? We squared. So honestly, I'm going to walk back something I said. We should put our answers in this because this was the safe one before we did any silly stuff with exponents and stuff. So I'm going to walk back. Don't put it anywhere but there. So with your calculator, you're going to want to use it. We're going to type in I'm going to copy this down to the bottom. So there's too much color and chaos on my screen right now. So we're going to type in -3 minus the square root of 9 plus 1.24. And I switched it to plus because it was said minus in the original problem, but minus the negative that I'm going to put in would, of course, turn it to plus. And I'm just going to let you do that. Like I know what the answer is because I worked it out yesterday, but if you type that in correctly, you should get all the same thing. What'd you get? That is correct. So this says negative 6.2. Again, all I'm trying to accomplish right now is figuring out is it a legit solution or is it a hoax? Is it an imposter? And now we're going to take negative 1.24 and we're going to put it in the right side of the equation, which will look like this. The square root of 4 times negative 1.24 plus 5. And I'm not making this up, right? This came quite seriously from the very first problem that when we copied it down. Type that in and what do you get? You want to say that again? You want to try that one more time?
0.2. Oh.
0.2. I mean, either one would have accomplished our mission here, and our mission is just to make a call. Are they the same? They're not. Therefore, negative 1.24 or negative whatever I said, 26/25, it's not, or 20, whatever I said. It's not a solution, so we can cross it off. So we can say x equals negative 31/25. You, sir, are out. Okay. And then we have to check 5. So we're going to go through the same process again. Only this time we're going to be plugging in 5s, which will be a little bit less stressful. You don't need a calculator for this one, just for the record. I mean, all of you, none of you in this room need a calculator for what we're about to do. Okay, just work through it. What's 9 minus 5? 4. What's the square root of 4? 2. And what's negative 3 minus 2? We get negative 5. So what we're trying to figure out now is, does negative 5 equal whatever we're going to get on the other side? And on the other side, we have to do the square root of 4 times 5. Just changing x into 5 plus 5. And what's 4 times 5? What's 20 plus 5? What's the square root of 25? Does negative 5 equal 5? And after all of that, it almost feels like a real letdown, I guess. What can we say? There is no solution. Okay, we found two numbers that could have maybe been solutions. They were candidates. They had hope, but it turns out they both flopped. They're both what we call extraneous solutions, meaning that the overall answer to this problem is that there is no answer. There was never a solution to begin with. So that one problem took us about 25 minutes, right? There's a lot of A lot of meat on this bone. So let's not try to do any more notes together. Let me hand out the next assignment. And if you want, we can do like the first problem together. Or you guys can go, oh, let's do number 5 or whichever one you want to do. I think I have 8 problems on this assignment. What's 8 times? Let's say you can do one in 20 minutes. What's 8 times 20? How many hours is that? 2 hours and 40 minutes.
Oh, boy.
Oh boy is right. I'll pause this while I'm walking around. Yes, ma'am. The left side, so number 1, the left side is obviously 3x plus 9. Does anyone think they've successfully tackled the right side?
No.
What do you think it is? Dib.
How are you gonna write it down?
That's how you do it right there. So, I mean, in theory, you could copy that down onto your paper, but what's more important is that you understand that that's a process you need to know how to do. So Morgan, for example, did that mentally. She just square, square, multiply, doubled it in her head. For those of you guys that maybe have been gone or are a little bit confused, you would, of course, out of respect to the math gods, you will go off to the side and do 3 plus the root of this times another 3 plus the root of this. And you would multiply it out doing the whole 1, 2, 3, 4-step process. So I leave that up to you. But great job. Great job getting there. So so Coulter, what I would do is I would so I'm always going to pay attention to the following question. By the way, I don't care where the red term goes because I'm eventually going to square it. And if it winds up with a -6 in front of it, it's just going to get squared and become a positive anyways. So the point I'm trying to make is this. What I'm always going to pay attention to here are these 2 red terms because I want to set the problem up so that the x's don't go negative. So what I'm trying to tell you is that I, in this case, will 100% move this over here because that will guarantee me that my x's stay positive. So like I'm going to have 13 x's over here. And then I'm going to have no number because the 9s are going to go 9 minus 9 is 0. And that's just going to be 13x equals 6 roots of -10x. So this is actually going to be a pretty relaxing and interesting problem because we don't have that extra term to bug us. Is this what you got? Nice work. Do you want to keep going? Okay, bud. Number 1, you get to this point that looks like this. Let's just do this right now. I got 4 minutes. Let's use them. So this is what you should have come to here. If everything has gone well, you get here. When you square this left side, you get 169, but with x squared. And then when you square this right side, ooh, good Lord, you get a 36, and then that's going to multiply by -10x. Are we okay with this? Okay, now what's going to happen is you're going to get 169x squared equals -360x. And quadratics can be a tricky because they change. They're like little tricky goblins. And every once in a while, you get a quadratic like this that says blah, 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 x squared plus blah, 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 x, but then there's no term where you're used to there being a term, right? When there's a term there like a +4 or a -81 or whatever, that's when we put the 2 sets of parentheses and do our trial and error bit. But in the absence of a number here, if you just go right to the 0, you'll remember from your past that these are the types of problems where we go, oh, these both have x's. So we GCF out that x and we're left with x times 169x plus 360 equals 0. And I use different colors here so I can talk to you better. We have 2 factors now. One of them is red. What makes the red one equal 0? How could you make the red one equal 0? What could you put in place of x? 0 is the only way, of course. It's just x. And then the green one is x equals 360 over 169. Those are your answers. They're just not answers yet. They're candidates, right? So now it's your job using your technology, your handheld calculator, to test them. You probably don't need your calculator to test zero. I'm hoping. But you probably want to use it for negative 360, 169s. And if I try putting that into my calculator to convert it to a decimal, 360 divided by 169. It's not the kind of decimal that I necessarily want to use. Honestly, though, if you're still listening, it might serve a purpose. If you wanted to approximate this, if you just hate fractions so much and you're like, I won't do it, you could say, well, it's about negative 2.13018 would probably be enough places to get enough accuracy to decide if he's good or bad. But that's rounded, so it's not perfect. Do you get what I'm saying? So your job, I'm sorry to make you be quiet and listen more, but like I just wanted to make sure we all get eyes on this. Not all quadratics are going to be make two sets of parentheses. What are the signs? When it's missing its C term, that's when you got to pull out the X and do it a different way. Right, right?
Did you use the calculator when you were talking about that?
Oh yeah.
Okay, we thought you just did that. in your head. You're like,
No. I mean, part of me thinks I could have just lied to you and said, yeah, I did that in my head, but no. Well, I'm flattered that you would have believed me, but no. God, no. That's all the calculator there. So obviously we'll work on these more Monday.
Um,